Today back on the Intelligent AI series. So if you remember in the last video we started we actually finished the AI series, so to speak. So we kind of reached a level of completion that I thought was suitable. So you can see here that kind of each turn gets better and better and better, but there's no actual way of proving that it's getting better aside from the amount hit. There's no time, there's nothing telling you how long each one's taking, and how it's getting there and how it's doing. So what we're going to do in this video is we're going to add that visual feedback in. I did say we'd do this in the last video, and we are going to be copying over from this because it does get a little bit complicated, but I'll try and explain it as we go along. So we're going to ignore this only display the quickest stuff for the moment. Basically all that's saying is, in the event that our times have been consistently the same, we're going to set this only display quickest to be true, at which point it's only going to show the quickest. And in that scenario, it's going to show you how many steps take, how long it took basically, and the amount hit on that run. So no, it's not going to display even. It's going to freeze the iteration basically. But that's kind of not essential. We're just going to keep running it forever. So technically, if you ran it for an infinite number of times, it would reach the best scenario possible. So anyway, we're going to go with the standard loop. Apart from this time, we're going to add 1 to the steps. We're also going to add a few spaces there because that looks horrible, and turn them lock on. So the reason why we're adding 1 to the step is because as default we start on 0, and in order to get our list we're timesing by I. Now if I is 0, then this wouldn't work. I mean, we'll leave it as is. It works. Anyway, we're gonna then set. I mean, this isn't necessary actually. We're gonna leave this for the moment. We're just gonna go with this standard loop, and we're then gonna just do draw text. This is a very standard list drawing bit of code as well. So you've probably seen it in some of the older videos. Going back to the RPG videos, I did these lists quite a lot for quests and stuff. But yeah, I'll talk you through what's going on here. So this is just the X, it's constant. Here you have the Y, so that's a little bit more complicated. These can go away. So 50 is our constant, so the very first one is going to be at 50. And then what it's saying is we're going to move down 20 at a time. So it's going to go 50, 70, 90, 110, etc. And you can change this to be whatever you want. In theory you could change the constant to be anything, that would be easiest. If you're changing this number, make sure it's kind of bigger. It'll just leave bigger gaps in between basically. I think if it's any smaller then they overlap and it doesn't look as nice. So yep, but I guess if you're using different fonts then it would be necessary. Then we're going to use this time for step, add in the step, add this one. Just going to put a little colon there, and then the times. I don't know if we've actually made a times, have we? Let's see. We will have set it up here. No, we've not. So we need to make a times. It's quite important. What do we? Let me just check the. Just had a sudden thought that possibly times is irrelevant. Where do we set it? My own code is fooling me. Doesn't even appear to. Oh, there it is, times. So it's max time. Okay, we'll go with that. So we need to add that in the step event. Where did we do it? In the run first population. Just under here, times steps equals, yeah, okay, yeah, this is, okay, I'm being really stupid here. Basically the times array holds the times for each generation rather than each individual thing, which is what the final steps holds. So that should do us. We do need to do in the create event though. We need to make the thing itself. We need to technically have a cap on how many times we do this. So let's just go with the population size for the moment. If you were running it an infinite number of times, then you would need this array to be bigger. But for the moment, our population size is like, what, 300 or something. So in theory we shouldn't go over that, in which case we've got a bit of a problem. So we're just going to set it as default to -1, and that will definitely show us if we've got an error then. So this is the only bit of code we need. If we go here, just like that, we need to divide it by room speed apparently, and I believe that is everything there. I think that should do us. Let's give it a go. I will full screen that in a minute as well. Time for step 1. Brilliant. Man time. So we see a little typo there. That's meant to be max time. I believe we've got that set up. Or have we? We do, yeah. So this is a bit of a problem, but we'll hopefully fix that. That is interesting. It's definitely not right. I don't know what this is in. I don't know if this is steps or what, but it's not right. I'm guessing it's to do with our max time, because we did make some very minor changes which might have messed something up. So okay, let's go back here and let's not times it by root speed. Yeah, let's do that, because I think what we've done there is we times it by room speed twice, so it's getting some crazy large number and it was minusing the alarm. So there we go, that's better. Okay, so that is done in 5.37 seconds. This is definitely not right though, we need to change this. There we go, 3.93 seconds. I don't know if that's actually right or not, but it might not be precisely right in terms of seconds, but we can look at it and say, well, it's improving. So each time it's improving, so regardless of what this is, whether this is seconds or whatever, I think it is seconds, but you can see it's improving. I mean, you can see this visually, but it's nice to see this little overlay. We're going to fix that thing though there. So let's get rid of the steps +1. Yeah, there we go. I think that would do it. I'm not entirely sure why we put steps +1 in the first place. Oh, I think it was so that it could do it quicker. Yeah. Okay, so there we go. That's making it a little bit nicer. So 5.37 seconds. Yeah, basically if we kept this running, it would just keep getting more and more efficient until eventually, oh, I'd say we're going to full screen that as well. Until eventually it reaches the best possible solution that it can find. Of course, it won't find the best solution, because to find the best solution it would have to run infinitely. It will reach a point where it's kind of an okay solution, so it'll get there relatively fast, but because of the level of randomization, there'll never be one that's perfect, almost. you could change this, or you could make it smaller even by changing the amount of variations, the amount of mutation. So make it smaller, it would find a more efficient path, but it would take longer. You make it bigger, it would find probably a least efficient path, but it would probably be quicker. So it's kind of like a toss-up. Kind of depends. So yeah, we can keep going. Okay, to go down to 1.1 second. It will eventually cap at something like this. You can see there it's gone up a bit there, which shouldn't really happen, but yeah, it's kind of decided that 1.1 is probably around the best it can do, maybe. But there you go. I found that basically you'd run it for a long time and it would do a long list of the same thing, and then all of a sudden it will just jump down a bit. I'm not sure why it's going back up again though. That is very odd. But yeah, I was going to full screen this, didn't I? So this is the code just here for making that little list there. As you say, I might recognise it before. It has been used before, but this time it's just got a few variations. So yeah, if you like this video and this series overall, remember to like, subscribe, what do you guys want to do, and I will talk to you in the next one.